Hello, I am Pratham Ajitnara, and today I'm showcasing the project of Amazon Delivery Time Prediction. As you know, in today's commercial landscape, unpredictable delivery time leads to customer dissatisfaction and operational insufficiencies. Our project tackles this predicting delivery, estimated time of arrivals using machine learning. The core problem is that the customer face unreliable delivery windows, business struggle with source allocation and routes, external factors like weather traffic introduces unpredictability. I'll speak about the solution now, a data-driven system that analyzes historical delivery data to predict times with 85 to 90% accuracy enabling dynamic route adjustment, realistic customer ETAs, 50 to 20% reduction in late deliveries. Speaking about the business pain point, is late deliveries is equals to customer churns. Insufficient route is equals to higher cost. And statistic estimation time is poor experience. Speaking about data challenges, multiple influencing factors such as distance, traffic, weather, agent, and performance. And the second one is non-linear relationship between variables, need for real-time adaptability. So basically, the project goal is to build a predictive model that estimates delivery time within less than 1 hour margin, accounting for dynamic conditions. Going to the project, so the code that I have written is all here, data wrangling code. Now, I'm going to speak about the EDAs, that is charts. The first chart that you can see on the screen is about delivery time distribution. So that it analyzes and examines the distribution of delivery time using histograph and KDE plots. So the key findings is the most deliverables 96%, 68% complete within 2 to 6 hours. 5% of delivery took more than like 12 hours. Right skewed distribution indicates occasional delays. Speaking about the business impact, the positive that core delivery operations are predictable. And negative, extreme outliners suggest operational bottleneck needing investigation. The second one is weather condition impact. In this, the box plot compares delivery time across weather's condition. Uh, I'll go to the key finding. The sunny is 2.8 hours average. The rainy is 4.3 hours average. And the storm is 5.8 hours. This weather explains 15% of delivery time reliability. The third EDA that I have used is traffic condition. Violent plot like plot delivery time distribution of traffic levels. Like low traffic equals to 2.8 hours average, and the high traffic is 4.9 hours. Yeah, yeah. Peak delay hours is 8 to 10 a.m. and 5 to 9 p.m. Chart 3 is about the weather. That in sunny it is 2.8, rainy is 4.3, and storm is 5.8. Going on the fourth, now let's move on to the fourth EDA, that is agent performance. The box plot of delivery time by agent rating and scatter plot by age. The key findings is 5-star agent goes to 3.2 hours average. 1-star agent goes around 4.5 hours on average. The agent age showed negligible correlation with performance. The chart number 5 is distance analysis. And scatter plots of delivery time versus distance with regression lines. The key finding is strong linear relationship, like plus 4.2 minutes per kilometer, that is less than 5 kilometers, 2.1 hour on average, and 10 to 15 kilometers is 4.8 hours on average. A 5% of short distance deliveries took less than 6 hours, that is urban congestions. Chart number 6 is product categories. The box plot compares delivery time across product categories. Key finding electronics is reaches in 2.3 hours, furniture in 6.8 hours, that is 3x longer, and groceries in 3.1 hours with low variability, which is prioritized as well. The chart number 7 is time based trend. It analyzes line chart of delivery time by hour, day, and weekend comparisons. Like key finding weekends 15% faster than weekdays, 15% faster than weekends. 3.8 hours into versus 4.4 hours. The best day is Wednesday. Worst day is Saturday. Peak delay hours like 8 to 10 a.m. and 5 to 7 p.m. Then moving on to the chart number 8 is vehicle efficiency. The box plot and scatter plot of delivery time by vehicle type. The motorcycle reaches in 2.1 hour, the truck in 4.5 hours. Vans optimized for 5 to 15 kilometer range, and the vehicle choice extends 20% of time variability. Going on to chart number 9, this chart is for urban versus metropolitan cities. And chart number 10, the correlation heat map. A heat map showing pairwise correlation between all features. Saying about the key finding, the strongest correlation with delivery time, distance kilometer plus 0.65, traffic high equals to 0.58, weather range 0.42, agent rating minus 0.35. Now, moving on to the ML model. The first I've used is random forest regression. Random forest is ensemble learning method. The core idea is that a crowd of experts is wiser and more accurate than a single expert. Instead of relying on one complex decision tree, it builds hundreds and or thousands of simple decision trees and averages the prediction to get a final, more stable result. Forest is like forming a large community of diverse experts. Random data. Each expert tree is given a slightest different random subset. So speaking about my in random forest in my project, it gives robustness. It is not easily thrown out of the outliers like a single unusual long delivery. Simplicity. It has fewer critical hyperparameters compared to boosting models. The feature importance is like it provides a clear and intuitional method of which factors like distance kilometer or preparation time minutes are most important in its prediction. Moving on to the model number 2, which is the XGBoost regressor. What is it? XGBoost is a powerful and highly optimized implementation of gradient boosting. Unlike random forest, where experts work independently, gradient boosting is a sequential, team-based approach where each new model corrects the error of the one before it. I'll directly move on to the strength about the strength in this project. It is high. The higher accuracy is the core strength of the project. It is widely recognized as one of the best performing model for tabular data, often winning machine learning competitions. Regularization. It has built-in mechanism to prevent overfitting, making the model more generalized to new data. Then third and last is flexibility. It offers a vast number of hyperparameters for fine tuning. Moving on to the last model is Light GBM. Light GBM is another gradient boosting method model, like just like XGBoost. It follows the same sequential error correcting principle. However, its key innovation is how it builds its tree, which makes it incredible fast. XGBoost builds a complete layer of the tree before moving to the next, whereas Light finds light with GBM finds the one that will provide the biggest improvement and split it, leading to unbalanced but highly efficient tree. Just like light GBM is a manager who says, forget symmetry, find the single biggest mistake, and we are making the right now the focus of all our energy and fixing that one thing. Here, it gives speed. It is significantly faster than XGBoost, which is a huge advantage for quick experimentation and returning. Performance. It often achieves similar, even slightly better accuracy than XGBoost. Efficiency. Speaking about efficiency, it requires less memory, making it suitable for very large dataset. This is why it was chosen as a final and best performing model. Now, I will move on to the next to deployment of this project. I'll show you the final deployment. Means like the final deployment using Streamlit that I've done. So this is the Amazon delivery time predictor, which I have done using the Streamlit deployment. The first, we have to take the location distance, like from the restaurant to delivery or something like. Then area type means which is the urban or metropolitan or semi-urban. Then the current weather condition or the forecasting weather condition, you might say. It's like sunny, cloudy, rainy, windy. In traffic density, vehicle type, which type of the vehicle that motorcycle is, scooty or electrical scooter or something like that. Then order date, order time, pickup time, then age, then agent tracing and that all. So the predicted time delivery for the data for the sample data that I've given is 32 minutes, which is a quite accurate thing, I guess. So thank you. That's all for my project.